Video we will talk about the concept of a cylinder, and the directrix and ruling are two terms which come into this concept. So by definition, if C is a curve in some plane gamma and L is a line not in gamma, then all the lines that are parallel to L and touch C, they form a cylinder. Okay, the line L is called the ruling and the curve C is known as the directrix. So let's say an example here. So for example, our first example is that our plane is the xy plane and our ruling is the z-axis and our curve is the equation of a circle. So this is a circle with a radius of 1. Okay, so the cylinder will go our well-known cylinder which has a circle as its base and it has perpendicular lines around it. So this is a cylinder in which the z-axis is right in the center of that cylinder. This circle is in the xy plane and it is the unit circle here, and these lines are parallel to the z-axis. Okay, another example to just show that this does not have to be a closed curve. So for example, if our curve is given by this x plus y, absolute value is equal to 2. So this means that x plus y can be 2 and x plus y can be minus 2, correct? So then this line is the x plus y is equal to minus 2 line, and this line is the x plus y is equal to 2 line. And then all we do is we make a plane which is parallel to the z-axis and passing through this line for this part, and we make a plane which is passing through this line and parallel to the z-axis for this part. So now it shows that this is still a cylinder, but now it is not closed. Okay, so by technical definition it is still a cylinder. All right, so now the convention, let's read through this. The convention is to choose gamma as one of the coordinate planes. Coordinate plane means like xy plane, yz plane, or xz plane. Okay, and ruling to be the axis parallel to the plane. So if we have xy plane, then ruling is z-axis, and if we have yz plane, the ruling is x-axis, and so on. Okay, so now if our gamma is the xy plane and the ruling is the z-axis, then a point xyz is on the cylinder if and only if the point xy0 is on C. This is understandable because the ruling is the z-axis, right? This means that the equation of the cylinder in xyz dimension is the same as the equation of C in the xy plane. So what we want to say is this. So now if, for example, and this concept can be extended to zy plane or xz plane. So now let's say this is the equation in the zy plane or yz plane. Now this means what? This means the either we have y is equal to 0 or z is equal to 0. So this means this represents xz plane and this represents xy plane. So all we have to do is we have to draw this plane. This plane is the xz plane in which our y is equal to 0, and this is the xy plane in which our z is equal to 0. So the union of these two planes form the graph of yz is equal to 0. So the point here we want to say is that even if we have, let's say, y is equal to 2x plus 3 and we want to draw it in x y z plane, so all we have to do is, so y is equal to 2x plus 3 is a straight line, correct? So let's say, without going into how to draw this straight line, let's say that this is that straight line. Okay, then all we have to do is we have to just extend this into extend this vertically infinitely to make a cylinder out of it. Okay, so any point here is on that cylinder. If we remove that z part and make it 0, and that point, if that point is on our C, then this point is on the cylinder. Okay, so this is what we want to summarize. Okay, so this is the small introduction about the cylinders and how it is used in technical terms, to so to speak. It can be closed or it can be open, and usually we use the planes to be coordinate planes and the ruling to be the perpendicular line to the coordinate plane. So this is about this video, and hope you hope it was clear enough to understand. Thanks for watching. Hope you liked the video.